Yeah, go ahead.
Yeah, Karthik, I'll just explain the problem statement. We need to find the winner of some election that happens. Winner of some election based on the votes. For example, let's say there are four candidates A, B, C, and D, where votes equal to A, comma A, comma B, comma B, comma A, C, comma D. So here A will be the winner who is having the most votes. So I want you to come up with a logic for this, and I want you to go through and help me understand where and all we need to assume few other things also.
Does the winner need to have more than 50% of the vote? Or suppose A has won 40%, B has won 30, C has won 30, then A is the winner?
The candidate with the most votes will be the winner. Yes, there is no.
So need not be 50%.
There is no cap. Yes.
So I'll repeat the problem. We have an election. There are a bunch of candidates, A, B, C, D, and you have an array of votes in a random order. And each entry in the array represents one person's vote. Now we need to find out who has won the election, right? And we have defined what winning means. We'll also assume that there are no invalid votes, duplicate votes, etc.
Duplicate votes in the sense?
One person has cast two votes.
Okay, no. So if it is A, and A, there is some voter who put A, then vote. Like first person,
Yes.
second person, like that. There is no duplicates. Yes.
Yeah, there are no duplicates. And people who have not bothered to vote, we'll just ignore them. It doesn't make any difference to us. And invalid votes, also, we'll assume there are no, or they have been deleted already. Like a person who has put the empty ballot paper in, or drawn a picture instead of, or voting for two candidates. And we'll also assume that what a person can vote for only one candidate, right? It's not a multiple.
No.
Okay. Okay, cool. So, and we'll assume there are few candidates. The voters may be very high in number, but the candidates are few.
Okay. Yeah. Okay. Let's say there is only four candidates, and let's say maybe. Okay. Can you repeat this point again, Karthik?
No, I'm just saying the number of candidates will be an order of magnitude less than the number of voters.
Yes. Yes.
Many orders of magnitude less.
Fair assumption. Yes.
So there could be millions of people, but probably 10, 20, max 100 candidates. Max.
Hmm.
So we'll create an array called votes, where the first element is the number of votes the first candidate has received, and likewise for second, and so on. And we'll initialize it to all zeros. And the size should be enough for the voters. Like an int32 should be enough. Because even if it is a country with a billion people like India, that will fit in a int32. Even a signed int32, which is 2 billion. India, China, all of these are less than 2 billion. So the data, so we don't need to worry about overflow. And then we'll just iterate through the votes array. And can I assume a numeric representation instead of A, B, C, D, 0, 1, 2, 3?
Yes. So you will
Yeah,
assign 0 to A, 1 to B, like that.
yes.
Okay.
So then I'll just do the total array. What is it called? Total of votes of I plus plus.
Sorry, Karthik, I am not clear. Can you explain
So
it
let
again?
me just chat in the Zoom, and then you can put it there.
Sure.
For vote in votes, just read it before sending it. For each vote, it will be 0, 1, 2, 3. And we'll also assume that all the values are valid. If there are 4 candidates, nobody has voted for the 8th candidate. For vote in votes, 1 second. Yeah, this is the loop I would run. If you can copy paste it into the editor you have.
Okay.
Right?
Yeah.
And then after this process is done, right? So votes is the array that you have given, and total is the array of total counts, right? So total will have 4 values in this example.
Okay.
And votes is the input array, which can be huge. It can be 1 million or something, billion, whatever. So now that you're, sorry.
I'll just take my example.
Yes. And then you'll just find which is the total, the highest value in totals.
Okay.
Find the index position, and that is the winner of the election. Now, there could be 2 people who have won the same number of votes.
Yes.
That's an edge case we need to handle. So we can declare multiple people as like the joint winner. Like we need to define what it, like how it works here.
Okay.
Like who is considered to be winning.
In the case of tie, the person who got the maximum vote at first, he will be the winner. Let me give you an example.
Earlier in the array.
Yes.
Okay.
In case of tie, for example, let's say A and B got both 2, but if let's say A got 2 votes first, A will be the winner.
Got it. Can we count the position of the last vote A has won? So find the position of the last vote A has won. Find the position of the last vote B has won. Whichever is lower is a winner. Is that what you're saying?
Just a quick. In case of A, the candidate who got the first max will be the winner. So these are our assumptions.
Yeah. So what I'm just rephrasing your 4th assumption. Just tell me if my logic is correct. In case of tie between A and B, find the last vote A has won. Find the last vote B has won. Whichever index is lower, that is the winner.
Okay. So now let's say.
So is that correct? Is that what you meant? Because when you say when there are multiple votes, you have to decide which one you want to compare. So I will say we'll compare the last one if that is okay.
Let me write it, Karthik. Even I'm not very clear. We'll try to replicate the same, and I'll walk through how it.
So I can just give you an example.
Let
me just try to come up with an example on the spot. Assume that if you wait, I'll just try to give you an example. That'll be easier to understand.
Yes, you can you can write it down and just share in the chat. I will paste it, then you can explain the solution.
Yes, let me do that. Yes, look at this example.
Okay, Karthik.
You have pasted it.
So A will be 0, B will be 1, 1, 0. Now votes I have initialized, total I have initialized. In as per
No,
your
no,
logic.
forget the logic. No, no, no. Just undo this. Just let's look at ABBA. That'll be easier to explain.
Okay.
Now, when you say who has won a vote earlier,
Hmm.
right? If you compare the first vote of each candidate,
Hmm.
then A will be the winner.
Yes. Yes.
Whereas if you compare the last vote of each candidate, then
Hmm.
B will be the winner.
No, you want me, I want you to calculate the last one as per your logic, last one. Because
Yes.
here B also got 2, A also 2. But
Yes.
who reached that max count first? That's our assumption.
Ah,
B,
I see. Got
yeah.
it.
Who got the first
But
max will be the winner.
yeah, I would like to challenge the question a little bit
Hmm.
because firstly, in an election, everyone's vote is the same value. You can't say some are more important than the other, which is what you are doing,
Okay,
right?
got it. In real
So
time,
that is
in case of tie, how it happens?
the coalition government is formed, no?
Okay. Okay, Karthik. Let's leave that. But here,
Yeah.
let's say that is the case. Let's say it is our logic,
Yes,
some
yes.
internal logic, some user
Yes, yes.
gamification logic.
Sure, sure, sure. So, yeah, so basically what I would do is I would create another array,
Okay.
which is last vote, and it'll have an array of, it'll be an array of size 4,
Again, pre-populated with 0.
pre-populated with -1. It's the signed array. -1 means invalid. Or just pre-populated with 0. That should also work.
Okay.
Now, in this for loop, whenever you increment it, you would also update the position. So you would say last vote of no,
What of?
yeah, last vote of uh vote, right? Yeah,
Hmm?
last vote of vote equal to I, the position. Of course, you have to change the for loop, but you can, yeah, that's understood.
Okay, got it. I'll do that.
So yeah, I mean we don't need to change the loop, right? We know how it works.
No, I
But it's
want to
understood.
print and see. A few edge cases we need to see and we'll run it
Sure, sure.
and where it is going on. Okay. No problem. I'll write it.
So let me tell you the complete logic. There's some more steps to do after this loop. Votes of I, yes. After this, find the max of the total array after this loop. I mean, just write it. Let max equal to last vote dot max. And the next line, total dot remove
Remove.
if
Hmm.
remove if value less than max. It's a closure. It's like filter or map or basically opposite of a filter.
Okay.
The callback will take one parameter, yeah, value. And val less than, yeah, that's it. Remove the
Remove
if, the if keyword. This is the return value.
okay.
Okay, so basically you have found the maximum value Then you removed all the, again, we are not talking about edge cases like there are no votes cast at all.
No
There are
problem.
no voters. There are no candidates in the election.
Hmm.
Those edge cases we are not talking.
Hmm.
We are not considering. So, yeah, so let's run through this logic first. Okay, so now, if total dot size equal to 1, just return total of 0. You're done. There's only one winner.
Return 1.
Return total of 0, not 1. So whoever the winner is, we are returning, right? There's only one winner. Got it?
Yes. I'll just make.
Now at the, yeah,
Sorry, go on. Go ahead.
yeah. At the last is one more line, which is a case where there are multiple. Not length equal to 0, length equal to 1. There will be one element at least who is max, right?
Hmm.
Yeah, so now it is 1. So now this case is handled. The case that is handled is there's only one winner. Now one more case we need to think about, which is the multiple winners.
Hmm.
Just do total dot max by py, max by, so now you're comparing two candidates, I and j. So it's a closure that takes two arguments.
Okay.
And you would compare last vote of I less than last vote of j. So basically it will run this operation on all the tuples in the array, and it will return the one who has the lowest value of last vote.
Can you type
Last vote of I
okay.
less than last vote of j. So let me just explain the logic.
Just a minute.
Yeah.
Okay.
And then you put a return before the max by, whatever the max value you're returning. Yeah, so let me explain the entire logic. You have a votes array, which can be very big. You have a total array, which is the same size as the number of candidates. There can be more votes, but yeah. And then you track the last vote position. You assume everyone's last vote position is 0. And you iterate through all the votes. And you get the vote. And you increment that candidate's score by 1. And you keep track of the I position. And because it is overwriting, it is keeping track of the last position.
Hmm.
And if someone has never got even a single vote, it will keep it as 0, but it won't matter in that case. Then you'll find the max. You'll remove all the values less than the max because those people have lost the election anyway. Now, if there's only one person remaining, you return him. If there are multiple remaining, I don't remember the syntax of this max by, whether you have to return true or false, but whatever, you may have to change the operator.
Okay.
But the point is, take the one with the minimum last vote.
Okay.
Now, this is the logic. Let me think about the. Do you want to write down the assumptions, or is that not required?
Assumptions have been already written.
Candidate with the most votes will be winner. No duplicates, no invalid votes. Yeah, point 3, even if it is not the case, the code will work. It's just an assumption. Yeah, one more thing is there is at least one vote. Right, which means there is one voter and one candidate.
Got it.
No duplicates, invalid votes. Yeah, this is what I would go with.
Okay. Let's go through the code again. So 0 represents A. We'll go with the same example, Karthik. Zero then A candidate has 2 votes, B candidate has 2 votes. Now here, as per our logic, we are iterating to the votes dot length, and we are saying that votes of I 0. In total, we are incrementing. So I'll just so first,
Yeah.
for a first iteration, total will become 1, another will be 0. Then for the next iteration, both will become 1, 1, 0, 0. In the next iteration, 1, 2, 0, 0. Then the final iteration, it will be 2, 2, 0, 0. Right, Karthik?
Yes.
Here in the last vote, for the first iteration, it will be last vote of vote equal to I. So last vote of vote will be last vote of 0th index will be 0 again.
Mhm.
Last then for the second okay, for the second iteration, last vote of 1 will be again 1. Stop me if I'm somewhere wrong.
Yeah.
Then 0, 1, 2, 0. The final iteration, it will be 0, 1, 2, 3. Correct, Karthik?
No, this, hold on. No, but this says that candidate D has won a vote and candidate C has won a vote. They haven't. The second two elements should always be 0.
Okay, got it.
In all the arrays, it should be the last two elements should be 0.
I'll remove it. The first iteration, it will be 0, 0, 0. Second iteration, the vote will be actually
A, no? So 1, 0.
hmm. Second iteration 1. Then again we are going 1 here.
No, it's not 0, 1. No, it is 1, 0. Because A has won a vote. A is the first time.
No, Karthik. So if in the first iteration, I is 0 and vote will be 0. Votes of last vote of 0 will be I, which is 0, right? Here in this
Oh,
iteration.
yeah. First iteration, yes.
Then the second
So,
iteration, we will get 1.
so hold on. This first value you have written 0, 0, 0, 0 is both the value before the loop and after the first iteration. It's the same value.
Okay. Before and after the iteration also same. First iteration.
Yeah.
In the second, we'll consider now. Now, vote is
To B.
yes, vote is B, which is 1. So last vote of 1 will be 1. Then 0, 0.
Mhm. Yes.
Here again, now I will be 2, vote will be 1. Then 1 will become 2 here.
No, that one will be as it is. The first value will become 2. Because A has, no, you're right. Go ahead.
Then finally, here we will come. Now vote is 0. So last of vote will become 3.
The second value will be 2. Yeah.
Okay. Got it, Karthik. Now we have the last vote index. Now last vote dot max, which is the third index.
Wait. Sorry, it should be total dot max. We are interested in who has won the most votes.
Yes. So max is 2 now.
Yeah.
Here, total dot remove if we are this remove if actually will iterate as per this condition.
Mhm.
Now total is actually this
2,
value.
2.
Value is less than max. Okay, finally it will be total will be 2, 2. Got it, Karthik? Now total is this is not the case. So here we will go. Now so if it is max by if last vote will be this one.
Oh, actually, we should compare the indices and not the values, right? One second, let me check. Let me think about what we should compare. So when you say max by I comma j in the total,
0 will be
it
less.
is not, yeah, 0 and 1. It won't be 2 and 2. So it won't be the values, it will be the indices.
Okay.
Typically, that is not how max by works. Max by gives you the actual values at those indices. It doesn't give you the indices. But
Mhm.
here we are assuming we have a function similar to max by, which
Which will
returns the,
actually compare the index.
yes. So actually, can do something else. This is unnecessarily complex. What we can do is, in the original array, I'll just give you a different logic which will be easier to understand, hopefully. If not, we can undo it.
Sure.
After calculating total dot max,
Okay.
just give some 5-10 blank lines where I can tell you what to type. So here I would iterate over this array, over the total array, for int I equal to 0, I less than total dot size, whatever.
Total array. Okay.
Um, if total of I less than max, total of I equal to 0.
Okay.
Now, so basically what we are doing is, whoever has won few votes, we are making them 0 votes. Actually, we
Okay.
don't need to do that. Hold on. Yeah, we don't need to do it. I think just cancel this line.
Okay.
We just iterate over them.
Mm-hmm.
You say for int I equal to 0, just write it. For int I equal to 0, I less than total dot size plus I.
Okay.
And then if total of I equal to max,
Okay.
now we have to check the last index value. So basically, when we iterate to the total, whoever has won fewer votes, we are not going to process that number at all, either 0 or few votes. Right? Only people who have won the max votes, we are going to process.
Yes.
And you want the minimum position. So I think I'll just tell you the logic. We can do the coding. Maybe we can skip the coding. But basically, the logic is, for each of them, just have two variables, which is winner, winner, and winner's last vote. Right? And you initialize them before the loop, right? To -1. And what you do is, if total of I, just find the last position. So wait, it has to be, we want the minimum position, right? So yeah, just write the code. I think it'll be easier. Next time, I think we should not do this on the mobile. It should be faster for me to write than to speak. Above this for loop, just define two variables.
Okay.
Let winner equal to -1. We'll see if -1 is the right value. Let winner position equal to max value. Whatever the max value of an integer is. There'll be some syntax in JavaScript. Right? In Java, you would say integer dot max value, whatever the syntax is. Just type integer dot max value. Okay? This is the maximum possible value, right? Or infinity. If you're using JavaScript, numbers are all double, so it would just be infinity.
Okay. Got it. So we can do something like infinity here.
Yeah. So because we want the minimum position. So if you initialize it to infinity, any number will be less than that.
Yes.
So if total of I equal to max, then you would say if last, so go to the loop.
Hmm.
Yeah. And then if last position of I,
Last vote of I, right? Karthik?
yes, sorry, last vote of I
Huh?
less than
Huh?
winner position. So
Hmm.
basically, you have found somebody who is earlier, right?
Hmm.
Then you would do winner position equal to last vote of I,
Hmm.
and winner equal to I, right? Is I the winner? Wait, what is I? Yes, I is the total, not the votes. Yes. So let's think about this logic. So first part is the same. You have calculated the total for each candidate and the last vote for each candidate. Then you have found whoever has won the max votes. Then you have kept two variables, the winner and the winner's last, winner's position. Can you just call it winner last vote position, just so that we are clear? 33.
Last vote position.
Vote, VOT. Yeah. Just copy paste it, no? If in other places it says winner position. Okay. So this is for the winner. What is the last vote position, right? And since we are going to decrease it, you have to initialize it to infinity. If you're going to increase it, you have to initialize it to minus infinity. So you're iterating through the votes array. If the current person has won the max votes, then only you deal with him. Otherwise, he is useless. We just ignore him. And also, the last vote for that person should be less than the last vote position, which will be true the first time around. Then you update the last vote position and you update the winner. So yes, this should work. Do you want to run through it?
Yes, Karthik, I'll do that. So just quickly comment out this. Finally, I'll console.log the winner. So as per our expectation, the winner should be 1.
Yes. Definitely connected.
Here also it will be votes of I, right, Karthik?
Yes.
It is returning -1. Can we debug this?
Oh man, this has to be done on the computer. I'm on the mobile. I actually come down from the walk.
Cool, no
So
problem.
let's see.
I think it will be very hard to zoom and see all these things.
No, I'm able to see it. One is I'm dictating the code, which is unnecessarily taking more time. The other is I can't debug it. But let's see. Console.log winner. Wait. So let me try to think about it logically. I won't make changes, run through the debugger, but I can think about it logically. If winner is -1, it means it never got assigned, because if it is assigned, I will never be -1, which means one of the two. Can you put a console.log between the two if statements
Yes.
saying hi? No. Okay. Yeah,
Oh,
good.
where
Yeah,
you want me to?
debugging. No, that's fine. That's fine. Just run it. Tell me, let's see which one it prints. Neither of them?
Neither of them are not. Okay, maybe this max, the variable I'm assigning is wrong. Let me check.
Yeah. Does JavaScript have a max with that syntax, or do you have to do something else undefined?
Let
Yeah,
me-
that's not the correct syntax.
Yeah, Karthik, it is working fine. Your logic is correct. Only thing is that max was the problem.
Is there any case in which it doesn't work, you think, or you think it's correct?
Let me see again. I think this logic is fine, Karthik. It will work. So we have maintained all the assumptions. So based on that, so for first, so there are majorly two cases where the candidate with major votes will be the winner. In case of tie, the person who reached that mark, that cap, he will.
Mm-hmm.
So both the major conditions are working. So other
Mm,
assumptions like invalid, duplicates, negative, those kind of all edge cases we are not assuming for the simplicity.
right. Those will also be trivial to handle anyway.
Yes.
Of course, duplicate votes we won't know because the array doesn't track who is voting. But other than that, we can handle them straightforward. Like if someone votes for a candidate named Z, they're only ABCD.
Mhm. Let me explain my solution.
1 second. Before we go to that, do you want to analyze the time complexity of this?
Yes.
So if you assume, so this is linear order of n, where n is the number of votes.
Hmm.
We don't need to worry about the number of candidates. If the number of candidates is C, let's say,
Hmm.
and then and the number of votes is V,
Hmm.
this is order of V. No, time complexity only. Yeah, both time and space complexity are the same for this problem. If the C is the number of candidates, V is the number of votes, both the time and space complexity is order of V.
Yes. That will be the case.
And
Yes.
yes, and we can't do any better because we need to check all the votes.
Hmm. Correct.
Now you can come up with smart logic such as, suppose as you go through, one candidate has already won more than 50% of the votes.
Hmm.
Then you can immediately stop counting the remaining ones
Hmm.
because anyway he'll be the winner. But
Sorry.
it will still be, sorry,
Can you repeat that, Karthik?
if there are 100 votes,
Hmm.
and as you iterate through the array, at some point you find that one of the candidates has 151 votes.
Which is more than half of that. So at that point,
Yes,
we need to iterate more
we
because
don't need to count the remaining votes also.
got it. Yeah.
And we are not assuming a two-level system. That's the other thing. For example, in India, in each constituency, you elect one representative, and then based on that, the prime minister is elected, right?
Hmm.
We are not going for that. And the assumption I talked about 51%, even then it will be order of V. But you can, in the best case, save half the time.
Yes.
Let's say the first 51 people have voted for the same candidate. Best case.
Hmm.
Which will never happen actually. So this optimization is not worth it. Unless it's like, it's like an African dictatorship where you have to vote for him, otherwise he'll kill you.
Okay.
Leaving those cases aside, some of those guys have won 97%. I think.
Hmm.
Leaving those cases, in a real democracy, it will always be few percentage. So this optimization is not required. Um, If the input is sorted, we could do something better. Some kind of binary search or something, right? We could just count. So basically what I have in mind is, suppose there are 10 candidates and a billion votes.
Hmm.
And if the votes are sorted,
Hmm.
like everyone who has voted for candidate A comes first,
Hmm.
then all the votes for candidate B, then all the votes for candidate C.
Hmm.
Then you can use binary search to find the first and last vote for each candidate
Okay.
and just count. Just subtract the max minus min plus 1 to find out how many votes each person has. So for the candidate A, for example, if the first vote is at position 100, second vote is at position 200, then the
Hmm.
number of votes A has 1 is 200 minus 100 plus 1, which is 101.
Hmm.
You don't need to iterate for each of those.
Yes.
In that case, it will be order
We
of
are
C
optimizing
rather
the
than.
we are optimizing the linear search over there, but we will miss out the tie situation, right, Karthik?
Oh, yes. Yes. So in that case, what you can do is, yeah. So yeah, the tie situation won't even work because if you're given the input in sorted order,
Hmm.
then the tie case has to be removed
That's
from the
why
problem.
because of the tie assumption, we can't give a sorted array.
Fair enough. So that is one thing. Um, what else was I going to say about this? Of course, in a real program, you would write a helper function.
Yes.
After that, the votes array will no longer be accessible. So just to avoid indexing into the wrong array.
Hmm.
And let me see what else can be done. Yeah, we discussed this. We discussed edge cases. Yeah, that's about it. Yeah, give me your solution.
Just give me a minute, Karthik.
Yeah. Just explain to me at a logical level once you're done.
Sure.
Try to
I
see.
won't write program and all, Karthik. I'll just explain.
Yeah.
Okay, Karthik. Here, my solution is little linear. A little linear in the sense is little simplified. Okay. So just iterate through the words.
Mm-hmm.
As per your logic, maintain two variables. Initialize with some default values.
Mm-hmm.
So the first one who got will be the so as soon as you reach the first index, you will compare.
Oh,
So you will increment the one, and the max winner will be currently A, then 2, then A, then B will be 1, B will be again, but we might need extra space for that. We need to track the candidate's number of votes, which will increase the space. I need to maintain an hash map or an object where I need to calculate also. Otherwise,
but
what will?
isn't it then same as my solution? You're just merging the two loops.
Yes, yes. But in this way, lot more computation. I assumed that lot more computation can be avoided.
I don't think so, right? Because the first loop in my code is
Hmm?
order of V.
Hmm?
Second loop is order of C, which is very small. So optimizing it won't make any difference.
Got it. Just a minute. Let me think it through.
I think your code will be simpler to understand. It won't have too many
In terms of
unnecessary.
processing power, yes, both will be almost. And
Yeah.
actually, mine is taking extra space.
I guess mine is also right.
Yours is also taking extra space, like total you are taking in another array, last word you are taking in another array.
Again, the total array, the extra space is again order of C, which is not to be worried about.
Mhm.
If you're taking order of V space, then you need to worry.
In my case also, it will be order of C, because I will be just tracking the, okay, more or less the same. So the core logic is we will be tracking two variables to track the max votes and the max. Yes. The only difference is mine is little simpler to understand, like you said. But you got my idea, right, Karthik? What was my
I
idea?
got your idea. Yes.
Good. Yeah, Karthik.
I mean, once you write it, I don't know whether it will be simpler to understand or not. But anyway, it's not a big deal either.
Good. Yeah, Karthik. That's it.
Is there any aspect to discuss? We discussed correctness, edge cases, assumptions, time complexity, space complexity.
Yes. We actually the edge cases covered most of the things we could possibly think in this time frame.
Yeah.
Yeah, Karthik.
Let's discuss a slightly different case.
Hmm?
Let's try to make this more realistic, shall we?
Okay.
So one is we'll assume that you have to win 51% to be the winner. Otherwise, you will declare the election to be hung or something they call it, which
Okay.
means there's no single winner, right?
Okay. Mhm.
So that is one thing. So actually, so that is one change we could make. The other change we could make is if I go back to your solution, I would remove the requirement of first person getting the most votes
Okay.
because order to me doesn't make. However,
Okay.
you order it. If you order by time,
Hmm?
you are saying that if you cast your vote early in the election, it has more value. That is not democratic, right? You
Mhm.
have a time, like a day or a week or whatever. In that, it should be the like any time you cast, it should have the same weight. So if I were to modify the problem, that is something I would remove.
Okay.
Um, I don't think it will actually ever happen. That
Yeah,
because
yeah.
when there are millions of
Let's
people, how
forget
can
about,
two
let's
people have?
not compare this with real democratic election, Karthik. Let's say it's like our own in-house product gamification kind of.
Yeah, yeah,
So this
yeah.
is very obviously it is arguable, but let's
Yes.
stick with the assumptions that these are the cases, and this
Right,
is
right.
the
In that
problem.
case, I think the discussion is done, right? There's nothing else to discuss.
No, nothing.
There's something interesting I learned about elections. I can share if you're interested.
Yeah, yeah.
One is in some countries, in many countries like India, US, etc.,
Hmm?
you don't vote for a party. You vote for a local representative.
Okay.
Like S. Raghu is MLA in my constituency. You vote for him or one of his competitors.
Hmm.
So it's a local view. The idea is that people know their local issues better than national issues.
Hmm.
Right? At least when India was formed and you didn't have all this internet, radio, TV, newspapers, all of these, right? People knew only what was happening locally.
Yes.
So the assumption was that, yeah, that is one thing. And people can influence their local politics more than national politics, right? So that's the assumption there, right?
Got
And then each constituency has one winner and, you know, at the country level, they total it up. Of course, one issue is that the sizes of the constituencies, right?
it. Hmm.
Because if one of them has 1,000 people, one of them has million people, then the weightage is wrong.
Hmm.
Right? You're saying that people in one constituency have 1,000 times as much weightage as people in another constituency, which is not fair, right?
Yes, it's not.
So ideally, each constituency should have the same size. So anyway, this is one way in which you don't vote for a party, you vote for a local representative.
Hmm.
In some other countries, I don't know if this is actually there anymore or not,
Hmm.
but it is also possible theoretically where you vote for the prime minister directly.
Okay.
So that could be another possibility.
Oh, okay. Okay. Got it. Got
So
it.
you say Modi should be my PM, right?
Hmm. Hmm.
And then whoever like BJP's representative is in your constituency will win.
Hmm.
So in this model, all the constituencies will have the same party's map,
Okay.
right?
Mm-hmm.
And in some countries, I think New Zealand is one of those. You
Direct.
cast two votes.
Uh-huh.
Sorry,
Go on, go on.
you cast two votes.
Uh,
Each person gets two votes. One vote is for the local,
Representative.
representative, right?
Mhm.
The second vote is for the national party or something, or the prime minister, whatever, right? At the central level, you are also directly voting.
Got it.
That is considered just an advisory vote, which means, or there's some other term they use, which means the purpose of that. So it doesn't have any weightage election wise.
Mm.
It is more like an opinion poll. The result will be printed in the newspaper and on TV and everywhere, but it won't actually influence the election. But it's just a way for people to express who they think is a good party,
Got it.
right? Because you could have, for example, let's say I think BJP is not a good party, but S. Raghu is a very good representative for my locality.
Mm.
And S. Raghu is from, let's say, in this example, BJP, right?
Mm.
So in that case, the two votes I would vote differently. The local representative, I would say, if I look at the issues that are affecting my constituency, S. Raghu, who is from BJP, is the best guy to deal with these issues.
Mm-hmm.
But at the country level, BJP is not the best party to run the country.
Okay. Okay.
So these two can be
So,
different as well.
got it.
And the second one is like I said, right, it doesn't have any weight. It's just like people expressing their opinion. It doesn't affect how the government will form or anything.
Okay.
And there are some where each person can vote for multiple parties. So if there are four parties and A and B are good and C and D are not, in your opinion,
You can vote for both A and B. Okay.
yes.
Oh, nice.
Yeah, and in some other systems, what happens is when they tally the votes, right, with multiple choices,
Mm.
uh, what they do is they find, tell me if there's a tie or something, right? Or if no one has reached 50%, right? So this also brings up the question of majority versus plurality. Plurality means you won more than anyone else. Majority means you won more than 50%.
Mm.
So uh, you could have a system where, like India, majority is required. If not, a coalition has to form, and the coalition should have majority, right?
Mm.
Or you could have a system where it's just based on plurality, in which case you'll never have a coalition government. So if A won 40%, B won 30%, C won 30%, A will win.
Okay. Because they are the majority.
No, they're the plurality. It's not majority because it's not 50%. It's called
Oh,
plurality.
single party which has the maximum. Okay.
Yeah. So that could be one way of doing it. I personally think that will be better because it will be more decisive.
Mm.
But anyway, that's a different political conversation we shouldn't get into here. There's one more thing where if you have multiple votes, one system I have heard of,
Mm.
everyone's first preference only is counted. You can also have preference. There's so many ways of doing it, right? So suppose there's no preference. You can just say A and B. I like A and B. You're not saying among A and B whom you like more, right? You're just saying A and B are good parties. Okay.
Mm.
In that case, yeah, you'll just count the votes and whoever won the most will win, right? Which could be more than the number of voters also, given that there are multiple votes, right?
Yes.
So that could be one thing. Another thing could be you could have a system where you indicate a priority. You say, I think A is best, if not B.
Mm.
In that case, what happens is everyone's first priority vote is counted.
Mm.
If no one has won, no one has crossed 50%.
Mm.
What they'll do is the guy who has won the least votes,
Mm.
he will be kicked out.
Hmm.
And for those people who have voted for him as the first priority, their
Hmm.
second priority will be respected.
Okay. Okay.
So there are like so many ways of doing this, independent of programming.
Got it. Got it.
Should I stop recording or any other comments?
No, Karthik, all good.